Good evening and welcome to the Vic South Star Party live stream presented by the Astronomical Society of Victoria and the Astronomical Society of South Australia. Before we begin tonight's stream, I would like to say that in the spirit of reconciliation, the Astronomical Society of Victoria acknowledges the traditional custodians of country throughout Australia and their connections to land, sea and community. We pay our respect to their elders past and present and extend that respect to all Aboriginal and Torres Strait Islander people today. I'd like to also announce that we have a raffle currently running. There are two prizes, of which first prize will be a Skywatcher Star Adventurer mini kit valued at $699. Second prize is a 40-inch long telescope carry bag. And for those astronomy nuts out there, it does not fit a 40-inch telescope in it, unfortunately. It's valued at $299, and we'd like to thank the team at TSA Outdoors for those wonderful prizes and for sponsoring the Vic South Star Party. The raffle is going to be drawn tomorrow night at around 9 p.m. And you can find the ticket link on the ASV or the ASSA websites. And as always, if you're enjoying tonight's stream on Facebook, you can donate stars, and those of you on YouTube can donate stickers. We appreciate all donations, no matter how large or small they are. And if you're watching us for the first time, don't forget to follow and subscribe to the ASV and the ASSA's YouTube pages. And tonight, we are proud to bring you Sky for the Night, presented by Perry Vlahos. Following Perry's Tour of the Night Sky, or Sky for the Night, we will be bringing you live images of the planets, as many planets as we can get. It's wonderfully clear out there. It's been a long time since we've done a stream where we've had clear skies, and we finally do. So if you have any questions about the objects we're looking at tonight, please pop them in the chat and we will try our best to answer them. But for now, I'll bring Perry in and hand over to Perry. Perry, how are you going tonight?
Good day, Mark, and good evening, everybody. It's great to have a little bit of clear sky, as Mark has said, and I'd like to welcome you all to a not so traditional Vic South, but it's about as traditional as what it was last year, which was also a digital presentation. But hopefully next year we may be able to do it in the flesh, live under the stars. Can I now put my screen up, Mark?
Yeah, I've already got it up there for you, Perry. So take it away. The floor is yours. Everyone can see your screen.
Let's make it a bit bigger. And I'll just explain a couple of little things about the program I'm using for those that aren't familiar with it. Normally, this activity is performed under the real stars in the grounds of the little desert lodge where Vic South is actually held, about 16 or 20 kilometres south of Nil in Western Victoria, with wonderfully dark skies, very little light pollution to speak of, and people with really good eyesight can see stars down to the 7th magnitude, so they say. And what we normally do, that's the first night of Vic South, is to invite the locals from the surrounding districts to come and have a night with us, and we share the universe with them by giving them a tour of the night sky with me and a laser pointer, a bit like what we're going to do tonight digitally. And then we offer them views through large portable telescopes, and it's an opportunity that the locals don't have there very often, and that is access to really large telescopes. I think The largest we've had to date has been about 25 inches, which is a very large telescope. So we then just have a look around the sky and explain what the main stars, planets, and constellations are. And then with the telescopes, as will happen this evening, with Andy and Anne-Marie, we'll be able to get a closer look through those instruments at some of these objects. Here we have the time, obviously the month, day of the month, and the year. And down at the bottom, we have the direction we're looking at, which is the south, and we can move around along the horizon to be able to look all the way around the sky. But what we'll do to begin with, and I always suggest this as the best time to begin observing the night sky, and that is straight after sunset, because then it's less confusing, as there are fewer objects in the sky, only the bright ones are visible, and you don't mistake one for another. So we're going to begin with some of the brightest objects up there, and if you've got a clear sky wherever you are, if you can take your phone outside with you whilst I'm giving this tour, you may be able to check out the real things or the real objects in the sky while I go through them here on screen. So for the latitude of Melbourne, the sun sets around 10 to 8 these days. Maybe as spring progresses, it'll be later and later. But no matter how late it gets, my cat Jove still wants to go to the door, the back door, to be let out. And I'm sorry about the...
He's like clockwork, isn't he?
He's absolutely... You know it well, Mark. You can set your watch by him. So Jove's outside, and he's probably looking at Jove, which is this object right here. So Jove is another name for Jupiter. And because my cat is red and Jupiter's got a big red spot, one of my, young students decided that Jove would be a good name for him. So the brightest thing you will see in the night sky right now, if you're having a look, is going to be Venus. Now, I know in our advertising for the event, we said that we will show the planets and the moon, but I think that's a typo, a little bit of false advertising.
We did update that one. It was a bit late, but we did update it.
That's good.
Yeah. When we realised the moon wasn't going to be up till nearly 3.
No, let's explain to the people why Vic South and really all the main star parties occur at times when the moon is out of the sky. Not that there's anything inherently wrong with the moon, but it's just so bright it becomes natural light pollution, and it affects all the fainter objects, which can be very interesting to look at in large telescopes, but it kind of blots them out with its glare. So most of the star parties occur when the moon is at last quarter or there's no moon at all. So Here we go. There's Venus up at the top, and as the sky gets darker, it becomes even brighter. In Melbourne, perhaps not in Adelaide yet, because you're about half an hour behind us time-wise. It's probably dark enough higher in the western sky to be able to also pick out Saturn, which is much fainter, and then Jupiter a little bit higher up as well. Now, you will notice that they're almost in a perfectly straight line. That isn't an accident. They're there because of something called the ecliptic, and I can put that in and I'll explain what the ecliptic is. The ecliptic is the plane of the solar system. In other words, if you can imagine a CD with a hole in the middle, not that anybody uses CDs much anymore, but the sun being where the hole is and the planets in those micro grooves stretching away from the sun. Now, they're not at 90 degrees or at 180. They are stretched out in a straight line, or what I meant was not directly vertically above the hole, nor directly below it. They're stretched along the disk of the solar system, and so you never find the planets very far from this line. If I pull out, you can see that it stretches all the way across the sky. And there's no point looking towards the south, for example, because the ecliptic doesn't go anywhere near the south, and so you'll not find any planets over there at all. So that's why they appear to be in a reasonably straight line following the ecliptic. And if we take out some of these other bits of paraphernalia around the sides, we can now look at Venus. I'll center it and we'll move towards it and have a closer look as we zoom in. There it is. Now, with a telescope, you will not see Venus like that, because the image of Venus I'm using here, or Starry Night uses, this program, is taken from images from a spacecraft that orbited Venus and was able to use radar to look under the very thick, cloudy atmosphere of Venus and look under it at the features. No matter how large your telescope is on the Earth, all we can see is the tops of the clouds that perfectly encircle Venus. So we've got a special view of it here, and later on through the telescopes, you won't see any of these markings underneath. Let's zoom back out.
You haven't paused the time, have you?
I'm sorry?
You haven't paused the time on your program. It's going to keep moving on you.
No, I don't pause the time, Mark. What I do is I center and hold things. Yep. So what we will see later, in fact, even if you're looking through your telescope, you're going to see half the planet in light and half in darkness, what astronomers call a dichotomy. And a couple of the other guests later on, Barry and Stuart, will be able to fill you in more on what that's all about, and they'll be able to explain more. So I'll not spend much more time on this, and I'll zoom back out till it becomes a dot in the sky. Now, as we come back from some of the zooming in that we're doing, you will see that more and more of the background stars become visible as the night gets darker. So the next planet we're going to look at is Saturn, and let's go in there and have a closer look at probably the jewel of the solar system with this fabulous set of rings. So that's a quick look at the moment, and as Saturn is the faintest of the three naked eye planets that we're going to look at this evening, it'll benefit from the sky becoming a little bit darker, and we'll be able to see some of its moons in a little while and have a better view of the rings as well. But now Jupiter, which is the next brightest thing in the sky after Venus, and we should be able to see some of the moons. There we are. And it looks like there may be a shadow transit there across the planet. I will back the time up a little bit and see, yes, there it is. So earlier this evening, this shadow, which is being cast by Callisto, I think at least that it is, perhaps Stuart or Barry can confirm.
We were watching that earlier, Perry. Before we went live.
Good.
Yeah. We caught it on Lee's feed of Jupiter. Just as it started to cross its path.
Yep. So really, in effect there, everybody, when you see a shadow transit by one of the moons across Jupiter, in fact, had you been able to stand on Jupiter in the middle of that black spot, you, in fact, would be watching a total eclipse of the sun. So that's what's really happening there. The shadow of the moon is casting that black dot, and it prevents whoever's in the middle of that dot from being able to see the sun, and creates a total eclipse of the sun. Of course, you'd be able to see the magnificent solar corona, which is the external atmosphere of the sun shining with this beautifully pearly light. And it's the only time that would be visible. So let's advance the time again And you'll note that Callisto just goes behind the planet. And as time advances, you'll be able to see this is Io over here. Europa. Io is a volcanic moon. Europa is an ice moon. And Ganymede is the largest moon of the solar system. Larger than our moon, in fact. So as the time advances, eventually you will see that Callisto will pop out from behind the planet, and let's see what time that will happen this evening. I'll just advance it some more. Taking its time. There it is, just popped out. So if you've got a telescope and you're out at about 1:45 in the morning, you'll be able to see Callisto pop out from behind the limb of Jupiter. And it's a fabulous thing to see live as it's happening. Now, here's something else which is not just a coincidence. You can see the cloud bands of Jupiter there, and the moons of Jupiter appear to be in a straight line. And again, that is an artifact of the ecliptic and the way that the planets orbit and the way that Jupiter spins on its axis. Let's go in and have a bit of a closer look at these moons. We'll not be able to see them like this through the telescopes, of course, but we can do it digitally like this. By the way, this is not a moon. This is just a background star. So if we zoom in to Ganymede, my apologies, Europa. Ganymede has moved in a lot closer and I wasn't paying attention.
So what happens when you don't pay attention?
You've got to keep your eyes open, soldier. Keep your eyes peeled.
Yep.
This is perhaps one of the most interesting moons in the whole solar system. And the reason for that is by using clever mathematics. Gee, these astronomers are smart. They've been able to deduce that, well, first of all, we could see that the planet is totally covered in ice, but we've also been able to figure out that the ice extends for about 8 kilometres in towards the centre of the planet, and under the ice there exists an ocean, a salty ocean that extends for many more kilometres after that. In fact, there is more water on Europa than all of the seas and oceans of planet Earth combined. So there's an awful lot of water there, and the thinking is that it's a prime candidate to be explored for life by having spacecraft land on the icy surface and then melt their way through the ice to the ocean underneath and explore for any possible signs of life. If you've seen some of the wonderful pictures that have come back from the Galileo spacecraft and others, the Juno spacecraft, was it Juno? Maybe I've got the...
I think it was the Juno spacecraft.
We've been able to see that some of these lines here, in fact, look as though from the cracks that material has welled up, and it seems to have a sort of browny, orangey colour sometimes, which may betray the possibility that it's organic in its content. And that is a very exciting element to contemplate when thinking about possibly exploring Europa for signs of life.
Now, Perry, we just had a question. I know you mentioned the program earlier, but Cigar obviously missed that. What's the program you're using again called?
It's called Starry Night.
Starry Nights. There you go.
Yep. Now, for members of the ASV, you can actually borrow a copy for free from the ASV library, which I'm sure will be back in business and open.
We are hopeful next Sunday that the library will be back open next Sunday. We're ready to go. We're just waiting on confirmation that we can actually open it, which is outside of our control. But yeah, Barry's ready. The ticketing system is ready for our members. It's ready to rock. We're just waiting on the Royal Botanic Gardens Victoria to say yes, you can use it.
Well, that's marvellous news, Mark.
It's great news, yeah.
Members can make their way down there, and which is I was just going to say Melbourne Observatory, but it's not. It's marvellous and fabulous Melbourne Observatory with amazing history that needs to be preserved.
Has wonderful history.
The best way.
We have a question from Tamara. Where's the library? So Tamara, the library is open to ASV members. Sorry to those of you in Adelaide, unless you want to battle the border and become ASV members. It's at the Melbourne Observatory, which is opposite the Shrine of Remembrance. It's probably the easiest way to sort of know where it is. And for the members of the ASV, we will be hopefully launching tickets to access the library from next Sunday. That's fingers crossed anyway.
Good news.
Perry, we have a question for you.
I hope I've got an answer, Mark, and if I don't, I'll just make something up.
Make something up, that's what I do. Do the planets vary in position along the ecliptic plane over a 12-month period, I'm guessing? If so,
yes.
If so, why?
Yes, they do, and it's because of their orbit around the sun. They're constantly in motion, moving easterly. Sorry, that's my phone. I'll get rid of it. There we go. Apologies about that.
That's all right.
So the planets are moving along the ecliptic constantly. They're not almost never stationary. In their path, they sometimes give the appearance of being stationary because of some other factors that are involved due to our position in what is going on here. Stop.
You're on another planet by the looks of it.
It does look like it. Let's go back home.
That
should fix everything. And let's go back to the west. So, yes, the planets are constantly moving along the ecliptic. And look, by and large, everything in the universe is moving, either along an orbit or spinning on its axis or whatever. And if they ever stop, then you know you're in trouble. So, yes, the planets will move east. And in fact, if I go in very closely, you will, well, you may not be able to notice it, but there is constant motion, and over the course of 24 hours, it's easy to perceive. So always look along the ecliptic for planets. I hope that's answered the question. If not...
I think that's a very good answer to the question, actually.
Thanks, Mark.
Yeah. And it was 12 months, so he was talking about, he's popped that in there, 12 months. So.
Oh, that's good. All right, so where were we? We were looking at, let's go back a little bit. Time-wise, whoops, the wrong way. What time will the show finish tonight, Mark? Do we have some parameters there?
Not necessarily. We kind of just we roll with we go with the flow.
Okay.
So you know, there's no massive rush. Obviously, we want to try and see Venus before it sets.
Yep.
But if somebody has a question and we have to come back to Starry Nights, then we come back to Starry Nights. So we don't have clouds as a problem tonight, which is good.
Give me a 5-minute notice when you want me to finish this up, Mark.
Yeah, not a problem. Not a problem. Keep going. You've probably got another 10 minutes at least, I'd say. So.
Okay. So here we are now with Saturn. It's a little bit later in the evening, and as I advance the time more, you will notice that another 1 or 2 moons will appear. This is Titan, second largest moon in the solar system, Rhea, Tethys, and Dione here. Let's advance the time and see if we get... Oh, there's another one that's popped in because it's a bit fainter. This is Enceladus. And again, with advancing the time, you can see them moving. You can see Enceladus moving under the planet there as we look at it. And zooming in, we get a better look of the rings and the planet itself. I'll go back to the west now, and we'll have a quick look around of the brightest stars and constellations.
Before you do, Perry, there's a very interesting question that's been popped up, and it is one that I know that Claire Kenyon and I covered recently, but it's a cracking question, and it's one that I actually wanted to know more about as well. Does the ecliptic move, or is it always roughly in the same spot?
The ecliptic doesn't actually move, but the Earth moves. And that is what moves it around the sky. So if I put the ecliptic in again, let's get it in there.
It's a good question, though.
Oh, of course. Excellent question. Now, through the course of an evening and also through the year, the ecliptic moves because the Earth moves on its axis through the course of an evening, and along its orbit over the course of a year. So it gives us different perceptions of the position of the ecliptic. So let's zoom out a little bit more, and I'll advance the months and watch what happens. So March, quite a different position. Through June and July, it becomes more vertical. August. So can you see what's happening there?
Yeah, the ecliptic's shifting in location. Well, it feels like it's shifting in location.
Well, it's actually the Earth, but the way it's a bit like to us, the sun appears to rise in the east and go and set in the west. So a similar effect is happening because of the motion of the Earth. So no, the ecliptic does not stay in the same position through the course of an evening or through the course of the year. I hope that's answered it. And that's why, for example, in the coming months over summer, the zodiacal constellations which are in the background appear to move further lower to the horizon if you're looking towards the north over summer. And in our winter, the zodiacal constellations such as Scorpius, Sagittarius, etc., are up much higher. In the summer, it's constellations such as Taurus and Gemini and Cancer, and they're quite low to the horizon. So it also gives us the low sun in winter, where midday on a winter's day, the sun is quite low in the northern sky, whilst in summer, say at the summer solstice, in about 2 months' time, it's up much, much higher, and it sees us casting almost no shadow on the ground, or very little shadow. The smallest shadow that we would ever cast at midnight occurs on the summer solstice. Conversely, in the winter, because of the low sun, due to the Earth's position in its orbit of the sun, we cast the longest shadow at midday. I hope that answers it, Mark.
I think it does, and it's very similar to what I have to deal with when I'm dealing with planning and shadows. I don't deal in the shortest or the longest. We have to deal in the average, which is the March, September. So all the shadow diagrams I have to do have to be based on the March and the September, because that gives you the average shadow impact of an object from the sun.
Yeah,
so it's a very, very, very similar theory. We've got another very good question from Andrea. Do these other planets have auroras like we get at the poles of the Earth? So does Jupiter, does Mars, does Venus, any of those planets, do they get auroras like we get?
Well, magnetic fields are important for auroras. You don't get them in circumstances where planets don't have magnetic fields, which means the core has got to be molten. Perhaps Stewart and Barry can verify that later, but some planets do have aurorae because of this, like Jupiter, for example, I believe has one, and also Saturn, possibly Uranus and Neptune as well, but I could be corrected on that by Stuart and Barry a little bit later on. I don't think Mercury certainly doesn't have one, and I don't think Mars has one. But I stand corrected, and it's an excellent question. We've got a lot of good questions coming forth tonight.
We get some crackers, I tell you what. We get some absolute crackers. So take us through some of these stars as well.
Yes. So the other thing that happens is soon after sunset, as I said earlier, the brightest stars become available, and not far, or they become visible first because they are the brightest, obviously, and it's less confusing. And near Venus currently is a magnificent star, a red supergiant, and it looks a little bit like Jove in colour, and you've guessed correctly, Mark. He wants to go out again.
He can't help it. Every time we talk about Jupiter, he's like, I'm out of here, man.
That's it. And stay out.
Yep.
All right.
You're not coming back, Jove. You're done for the night.
So Antares is a red supergiant and a truly, truly massive star. Its diameter is so huge that if we were to take, this is it here, by the way, and it's the heart of the Scorpion, otherwise known as Alpha Scorpii. If we were to take the sun out of the centre of that CD, the solar system, and to replace it with Antares, then Mercury would be orbiting inside Antares, but so would Venus. And it doesn't stop there. The Earth would also be orbiting inside Antares because its diameter is so huge, and so would Mars. So this is a big sucker. And
so is that similar to what will happen to our sun when it expands?
Excellent question, Mark. No.
No.
Our sun doesn't have enough mass to become a supergiant, a red supergiant, which is what Antares is. But it will swell, it will become larger, and Mercury may feel the influence of the sun, but it will never be as large as what Antares is. However, when it reaches its red giant phase, not supergiant, by then all of the oceans would have been boiled off Earth anyway, and there wouldn't be much life left, even though we wouldn't be orbiting inside the sun. By that stage, Europa, the ice moon of Jupiter, might be a good destination. So Antares, as I said earlier, is in Scorpius, and the shape of the Scorpions, or the constellation, is easy to discern at this stage of the evening. Now, it looks a little bit different to what it does when Scorpius rises in the east in autumn. Here's the head of the Scorpion, the body of the Scorpion, and the tail winding way up in the sky. Now, because of the Earth's movement and the positioning of the ecliptic, if we were to follow backwards, let's see if I can center Antares. It is already centered. If we follow it back to, say, May, for example, it will look quite different in its orientation. The head will not be down here, and the tail will not be way up high in the sky. It will be like this. Let's go backwards. But actually, that's a bit difficult for you to see, so I'll put in the shape. Let's do that. Astronomical. There's the shape of the scorpion. And if we go backwards, September, August, July, June, and May. So that looks quite different. There it is in April. Looks very different as it rises to where it ends up. Now, in October, nearly November, about to set. Let's take those.
It rotates quite a lot, doesn't it?
I'm sorry, Mark.
It rotates. It shifts quite a lot in that period of time.
And it's because of the moving of the ecliptic that we had from that great
question earlier.
Yep.
Yes.
So looking towards the south now, we're about to see our national symbol right there, the Southern Cross and the two pointer stars. So Alpha Centauri here, the closest star to us after the sun, and Beta Centauri there. This is Alpha Crucis, or A Crux, if you like. Crux is the Latin name for cross, and it doesn't need to be called Crux Australis, Australis meaning the southern, because there is no other constellation that's a cross in the whole of the sky, north or south. So Crux is enough to name the Southern Cross. But if you've got an affinity for heavy metal music, ladies and gentlemen, and I know some of you do, well, you're about to get a close encounter.
I know what you're talking about, Perry.
You've seen it. You've seen my show before, Mark.
You've shown me this before, yes.
Yes. Watch what happens as the evening progresses. So let's advance. The Southern Cross ends up standing on its head. And about 11 or 11:30 this evening is when it occurs. There it is. And it's at its closest point to the horizon. Now, in order to be able to see it, of course, you've got to have a very clear view to the southern horizon, no buildings, trees, or hills in the way, because it is very low. This particular star, for example, is only just 5 degrees above the horizon. That's Gamma Crucis, which is also a reddish-coloured star, just like Antares. But let's go back to where we were and see if we can spot some of these other first magnitude, which means brightest stars. Rising over here in the southeast, we have the magnificent jewel of the southern sky, and that is Canopus, the second brightest star in the sky. Notice I said star, not planet, and of course there's a big distinction there. And there's a satellite moving through the Large Magellanic Cloud, and you will see a lot of them these days because there's many of them in the sky. Right up higher, and this is the best time to see this star, spring, is Achernar, which is another quite bright star, what we call first magnitude stars, and there's about 20 of them in the whole sky. So that's another one that's a gem of the southern hemisphere and pretty easy to spot. If we move along the western sky, we also come across this other easy to spot star called Altair in the constellation of Aquila. If anyone has seen the wonderful 1950s science fiction movie called Forbidden Planet, dun da da, it is set on a planet around this star, which is about, I think about 17 or 20 light years from us. And it's where you will find Robbie the robot and all the shenanigans that go on in that movie. A wonderful early science fiction movie and a must for any science fiction fans, I think. Further along, one of the other great things in the spring sky, and I'll go back in time a little bit. I'll push time back so we can have a better view or make it easier to discern, is the great square of Pegasus, which are these 4 stars right here. Now, isn't it a marvellous thing that I've arranged for the flying horse Pegasus to be very dominant in our northern sky at this time of year, just in time for the Melbourne Cup? A fabulous juxtaposition of the two things. Now, the neck of the flying horse goes this way along these stars. This is its eye, and Enif is the nose here of the flying horse Pegasus. Its back legs or its hind legs go down this way, and in fact, they're not really part of Pegasus because they belong to the constellation Andromeda. And the other fabulous object at this time of year, though very difficult to see from Melbourne, at the Little Desert Lodge where Vic South takes place, there it is, by the way. We might zoom in for a closer look. It's a little bit easier to see, and you can just spot it with your naked eye. And the ASV possesses a fabulous large set of binoculars that give the best view of the Andromeda that I've ever seen. In fact, telescopes visually don't do it justice. But those binoculars up there just give a fabulous view. And I was fortunate enough one time to view through those binoculars before they were offered for sale to the ASV by Paul from South Australia. He had them at Vic South and it just looked stunning. I'll always remember that view. So there's the Andromeda Galaxy, and unfortunately, as we advance the time, it's at its highest when it's due north over our horizon. And even then, it's only a scant 10 degrees over the top of the horizon. So
I have some good news though, Perry.
what's that, Mark?
Andy is just near the South Australian border and he has nothing in his way, and he will be able to live image this tomorrow night.
That is tremendous news.
Absolutely tremendous. He won't get it all. He'll be focused, I believe he'll be focused more on the centre of it. But we'll be able to live image Andromeda Galaxy.
Well, I'll be looking forward to that.
Yeah.
And I hope
absolutely same.
Everybody else joins us to have a look at it tomorrow night.
He's just popped in a private chat that it'll be 12 degrees for him.
Yeah, that's good. Let's be honest about this, though, ladies and gentlemen. A live telescopic view of this object is not like a photographic image taken by the Hubble Space Telescope or Keck or even any reasonably large optical telescope with a good camera on it, because it's a different medium and cameras work differently to the eye. But being able to use your eye to see real photons live from an object out in deep space is just a fantastic thing. Now, keep in mind that the Andromeda Galaxy is about 2 million or 2.5 million light years from us. And that's light travelling at nearly 300,000 kilometres per second, which is a phenomenal speed. Should you be able to look back with a fabulous telescope from Andromeda that could look back at the Earth and you could see the Earth in amazing close-ups, there would be absolutely no sign of humanity whatsoever, because there would not be any humans on Earth yet. It would be looking into our dim past. And if you're on the galaxy, I think it's 4845 in the Virgo cluster, which is about 65 or 70 million light years away, and you still had this great telescope that could look back at the Earth, what you would be seeing would be dinosaurs.
We did a cracker the other week, Perry. I don't know if you got a chance to see it, but Anne-Marie, with her equipment, which she'll be able to show off tomorrow night, managed to image a galaxy that was 500 million light years away, the Cartwheel Galaxy, live for us. Yeah,
fantastic. No, I didn't see it. But
it was mind-blowing. It really was. Just quickly, I'm going to give you a 5-minute warning, only because we're going to lose Venus soon otherwise.
Okay, good.
It's been engrossing, though. It really has. It's been great.
The time on our stopwatch here, or our diurnal clock, is now just gone 11:29, and if you're up at that time of the evening, the eastern sky just comes alive with fabulous stars and constellations, and they're really something to look forward to over the coming months, ladies and gentlemen. Excuse me. Because we're going to be able to see the Pleiades, Taurus with Aldebaran. Here is Orion with Betelgeuse, another red supergiant. The Saucepan, which is really composed of the belt and sword of Orion. and Rigel, the blue supergiant. Sirius here, spelled Sirius, which is the literal Greek for scorching or searing, is the brightest star in the sky, sometimes known as the dog star. And all of these objects, and there's Canopus, it's moved up higher, will be available to us over the coming months, and hopefully we'll be able to view all of these objects, and I take great pleasure in perhaps showing them to you at the Starbecue in December from the ASV's Dark Sky site with a laser pointer in hand, and then we can go for another skip through the skies of the early summer. I think I might wind it up there, Mark, and thank everybody for their attention.
It's been a great little presentation there, Perry. So we'll get the others in. So we'll all jump back on stream, and welcome to everybody who is joining us. So we've got Stuart from Lunar and Planetary section, who's the section director. Barry Adcock, who's an expert in all things planetary. Noel and Anne-Marie and Frontout Astronomer, who is Lee, and Andy providing the images tonight that we're going to see live of the planets. Now, I think Andy's got Venus. Anne-Marie, have you got Venus as well?
Yep, I've just shared it.
I'm not being mean to Andy, but Anne-Marie's Venus is much better than
Andy's.
Would be. So I'm going to throw this over to Barry and Stuart and to Perry to tell us a little bit about Venus, if they can. So whoever would like to take the floor.
Just before we start,
Yep.
Mark, can I just mention something? You will notice that the image that we were looking at before when I was showing Venus had the opposite side being lit up than what is found here in this telescopic view. And that is because of the optical system of some telescopes in making objects to appear upside down, and sometimes also mirror reversed as well. But it doesn't matter because anyway is up in space. So thanks for letting me get that in. And now Barry and Stuart, please.
I think they've gone silent. Barry, do you have anything to add to what we're looking at here with Jupiter? Oh, sorry, Venus. Oh, I'll unmute you. There you go, Barry. I think Barry's struggling to unmute himself. Stuart, have you got anything you'd like to add about Venus while Barry tries to unmute himself?
Yep, so this is Venus live as we're looking at it, and it's Venus is the second planet from the Sun and is the Earth's closest planetary neighbour. It's one of the four inner terrestrial or rocky planets, and it's often called the Earth's twin because it's similar in size and density. These are not identical twins, however. They are radically different between the two worlds, but it's always totally covered in cloud, and we can never see the surface unless we use something like X-rays to peer through the clouds.
Yes, Mark, I was having trouble. I'm too used to using Zoom.
That's okay. We got there. Take it away.
I was going
Barry.
to make a comment about dichotomy.
Mm-hmm.
We measure the angle from the Sun to Venus in the sky as its easterly or westerly elongation, and Venus being west now has an easterly elongation. And when the elongation is at its greatest, if you study the geometry of the layout, that's when Venus will appear as a half. Now, dichotomy was theoretically last night on the 28th of October. But to the naked eye, we always see it early because the terminator of Venus is always darker than the limb. So we see the planet looking like a half or first quarter or whatever you like to call it. We see that early to the naked eye. But with modern photography, we can make Venus brighter if we wish, and we probably make the terminator much straighter than perhaps it is at the moment. So dichotomy was yesterday. Now,
so what time yesterday would dichotomy have been? Do you know?
I'm not sure
No?
I'm not sure of the hour, but
Well, come on, Barry. I thought you would know all that stuff.
Yeah, I could. If I can
do a bit of research, see what you can come up with.
Yeah,
I think we've got Venus for a little bit longer, so before it sets. So, Perry, did you have anything to add about Venus while Barry has a look at the exact time dichotomy occurred?
But I think the only thing I will add, Mark, is it's not particularly important that we know when dichotomy is. At this stage, the fact that it was yesterday is good enough for me. So,
according to my information, it was on the 28.61. So that would be probably universal time. Probably 14 hours universal time. It'd be roughly midnight or midnight last night.
How's that?
Anyway, it's
Barry?
not a particularly important figure. The other thing I was going to point out.
What's interesting, Barry, is as you read that out, the ASSA mentioned the same thing, that it was 14 hours universal time.
Yep.
So there we go. We've got the exact time of when it happened. So about midnight last night is what you're saying.
well, Mark, unlike astrologers, astronomers always agree.
They do, don't they? And they did on this occasion.
I was going to make a comment of interest, which is not necessarily as we see Venus now, but in recent times, there was this announcement of this discovery of phosphine on Venus, which is a colourless but very, very toxic gas of phosphorus and hydrogen, pH3. But that has actually been disputed, but it was important at the time because phosphine on the Earth is an indication of life. The problem we have is applying earthbound chemistry to Venus, where the pressure could be 100 atmospheres and the temperature 500 degrees centigrade. And, it's been disputed whether it was actually phosphine that was discovered. But if it was, there's still a dispute about whether it's a sign of life, but it could be actually generated by chemistry that's not all that familiar to us. So that debate lingers on, but we'll hear more about it in the coming months and years as people study it more closely.
So there's been something posted in our little private chat that pops up to the side that no one else but us can see. Does it snow titanium on the mountain peaks of Venus? Do we know that?
Sorry, Mark.
Does it snow titanium on the mountain peaks of Venus?
I'm not familiar. No, I don't know. I simply don't know.
We can dump Andy into that because that was his comment.
Yep, I've heard of it before.
That would imply that titanium was in the atmosphere, and I've got.
Yeah, titanium settles.
That's not an obvious.
Yeah, I've heard that titanium settles on the higher peaks.
Yeah, it does. Apparently, it does snow titanium on Venus.
Yeah,
there we go.
I'm not familiar with that weather phenomena.
Do we trust Google though? That's the thing. Google
That's
says
the thing.
it knows titanium.
It's very
But
quick.
do we trust
For-
Google?
For titanium to deposit on the peaks, it means that titanium is in the atmosphere. And
Yeah.
I'm not sure, as a metal, I'm not sure that even Venus is hot enough to vaporize titanium. Otherwise, it may rain as a solid. But I think, I'm not familiar with that phenomena at all.
Have you heard that, Perry, at all?
But yes, Mark, I heard of that just a couple of minutes ago.
That's about when I heard about it as well.
Yeah.
It's got to be true because it was on Google, I think, a while ago.
What was that,
it's
Andy?
probably useless.
You need corroborating sources and peer-reviewed sources as well. For
Yeah,
that to be,
I'm not sure how much I trust
Make
Google,
it
but
I've heard that it rains sulfuric acid, but not titanium.
there we go. Sulfuric acid. That one I would be comfortable with.
Wasn't
Yeah.
Not if you're there, you wouldn't be.
Not if you're there.
I wouldn't be comfortable if I was there. The umbrella wouldn't even protect me, would it?
No.
Wasn't there, Stuart, you might know this, wasn't there a Paul McCartney song about Magneto and Titanium Man? Maybe that's where he comes from.
I don't know if I'm familiar with that particular song, Perry, but maybe it does.
There is no shame in saying you don't know Paul McCartney's stuff, Stuart.
It depends
In
on whether you're
fact, it's
talking about
preferable
wings
to
or.
saying you don't know John Lennon's stuff.
Yeah, I would agree with that. So the only one I know song-wise would be Iron Man, Black Sabbath. So
Okay, it's not titanium. At the top of Venus Mountains is so hot. It's not snow as we know it, but it's two types of metal, galena and bismuthite.
Bismuth.
Bismuthite.
Yeah, that's what it snows.
Well,
The,
bismuthite is great for stomach ulcers, so let's get us some of that stuff.
Yeah. Well, stops the sulfuric acid dissolving, I suppose.
Yeah.
So I think what we might have to do, I think some of us have lost Saturn. So while we try and get Saturn, we might jump across to Jupiter, and Lee, you might need to, there we go. We'll dull it down a bit.
I was only just getting over there.
Thank you for doing
Venus
that.
was looking very low in the sky. You could tell by the
wobble.
atmospheric dispersion because it was very orange on one side and red on the other.
So, Barry, do you want to tell us a little bit about Jupiter? I know you're a big fan of Jupiter, and I've seen some of your spectroscopic work on Jupiter, and it's very interesting.
Jupiter, of course, is the largest planet in the solar system. It's about 140,000 kilometres in diameter. You could fit 11 Earths across the equator. But unlike, you see, when the Earth spins on its axis, our Earth actually bulges at the equator. And if I could read out a couple of our planet Earth, through the equator is 12,756 kilometres, but through the poles it's 12,714, which is roughly 40 kilometre difference. And that's caused by, that bulge at the equator is caused by the Earth spinning. Now, on Jupiter, of course, it spins 2.5 times faster. It's nowhere near as solid as the Earth, and Jupiter has a equatorial diameter of 143,000 kilometres, and through the poles it's 133,000 kilometres, which is about 10,000 kilometres difference. So to anyone either looking for the first time or any other time, Jupiter is obviously elliptical in shape. It's an oblate spheroid. And we point that out to people looking at Jupiter at the observatory for the first time. That's one of the first things they'll see. The current interest in Jupiter, of course, is the Great Red Spot. It has shrunk at an irregular rate over years, decades and centuries, and it's being said at the moment that it has never been smaller. Can I share a picture, Mark?
Yeah, go for it. If you want to share the screen, go for it. You share the screen, I'll pop it up. We're all good.
Share the screen.
While you're doing that, I just want to give a shout out to the LMDSS committee who are up at our dark sky sites, currently making the site ready for our members to get up there from Monday night for the first time in over 3 months, which will be wonderful. So big shout out to those guys up there working to make sure the site is safe and ready for everybody for our members to access the site.
As usual, I can't bring it up, but
That's all right. You get there, Barry. We're good. So Lee had a processed image of Jupiter that he just popped up. Do you want to pop that back up while we're waiting for Barry?
Yeah,
Lee,
so
you want to tell us a little bit about that?
basically, while getting set up earlier and sort of waiting, and while Perry was giving his fantastic sky for the night, in SharpCap I recorded 3. So I'm using a mono camera with filters, so I've recorded 3 individual 2,000 frames worth of images. Then I've extracted all of those and stacked them together, and ended up with that. So it's not a huge amount of processing to have done. It's only took me about 5 minutes or so. But yeah, I've managed to get the great red spot, or
Not bad for 5
semi-mediocre red
minutes.
spot. Yeah, I'll
rightio. Yeah,
You ready to rock, Barry?
I hope so.
Let's give it a go.
And
shall we?
you can actually just see the spot disappearing off the edge of the horizon now.
All
showed
Barry,
one of these
ready. Here we go, Barry. There we go.
Yeah,
All yours.
The picture on the left was taken by myself in 1971. It was taken on Ilford FP4 film, which was blue sensitive, so anything red comes out to be dark on the print. And 50 years later, I took that picture on the right on September the 23rd, which is only a few weeks ago, and you can see the difference in the size. And as the red spot has shrunk, it has also become more circular. At the moment, it's barely 1.5 times the diameter of the Earth. In fact, it's probably a bit less, but it is much more round than it has been in the past. In fact, going back even further than 1971, there are pictures and drawings of the spot that show that it's really been quite an enormous object. There's always an enormous amount of turbulence around the spot, as you can see on the right. To maintain the red spot is an anticyclonic or high pressure disturbance, and to maintain it requires a certain amount of energy. Now, we're not sure where that energy is coming from, and until we can extend our knowledge of the atmospheric dynamics of Jupiter, we really can't predict what's going to happen. Whether it's going to actually disappear again, or if it's going to get bigger or stay the same, we simply don't know at this stage what the future of the Great Red Spot is. I'll stop sharing that now so we can go back to...
That's a wonderful share.
Isn't it time then, ladies and gentlemen of the jury, and I put it to you that...
Who's the jury? Are we the jury? Are we the jury?
Well, you are.
Okay, we're the jury.
That it was once a great red spot. Now that it's shrunk a bit, perhaps it's just a good spot.
A red spot, the average red spot?
Just a good spot.
That's why I said mediocre.
The average red spot, the not so great red spot.
The potential red spot.
The red spot, formerly known as.
Yeah, very Prince-like. Maybe Barry's right, though. He said the potential red spot because that has the indication that it could either get better or bigger, or it could get smaller.
Yeah.
Have you got any...
Barry, can I ask Barry a question?
Go for
Barry,
it. Go for it.
with the size diminishing gradually, has the colour diminished over time as well? Because when it was first observed, of course, it was called the Great Red Spot. It's now, perhaps that was an exaggeration, and it's now more a salmon colour when you look at it with the eye. So is it possible that the colour has also faded over time?
No, I think the colour comes and goes, and it goes because cloud forms over the top of the red spot and makes it more opaque. And I think that coming and going of the reddishness of the spot is independent of the size. I think it has gradually got smaller progressively. There may have been a short time when it may have got slightly bigger, but it has gradually got smaller the whole time, whereas over the decades it has been salmon coloured or quite pale, independent of its size.
Thanks, Barry.
Yeah, I agree. Since I've been observing it on imaging it since about 2016, it was quite salmon coloured, and then it also went into being very bright red and then back to salmon again. So it does seem to vary.
So the ASSA is saying that it is a great red spot knot. I like the red spot formerly known as. Janine Hobson-Buck is saying that when you put the size of the spot in comparison to the size of the Earth, it is still a great red spot, and it is. Oh, here we go. We're getting all sorts now. The medium salmon spot.
Medium salmon spot.
It's still the biggest. It's still the biggest storm.
It's the biggest spot in the universe.
There's spot BA that's been lingering for a while, but the great red spot is still much larger, even though it has diminished in size.
So Mark Sanson is saying that it's wonderful, Barry, that you've kept a record of 50 years of imaging. And I agree. The fact that you have imaged the same planet 50 years later is a credit to you. Absolutely, that you've done that. And the difference in technology as well from what you were using back.
Thank you for those comments, but it does go back probably 60 years rather than beyond 71. But I was going to share another image if I could.
Go for it. Yeah. The floor is yours, Barry.
These are pictures that are going to appear in Crux in the next issue, but
shh, don't tell anyone.
I just want to point out the changes that take place. There are 4 pictures taken in 2018 to 2021, and they're supposed to highlight the difference of the North Equatorial Belt. Can you see my arrow?
We can. There we go.
My arrow is indicating the North Equatorial Belt.
Yep.
Very turbulent for 3 years. In fact, last year it was incredibly turbulent, but now it has faded away into a very skinny south component, and these little brown patches are called barges, and that's what's left of the north component of the North Equatorial Belt. So there's plenty of activity there. I'll stop sharing that picture, and I'll go to
So while we wait for that, this is a live view of Jupiter from Noel's telescope here. Which scope are you using tonight, Noel?
That looks very good.
It does.
Yeah, I've got my 180mm Maxitov.
The Maxitov, that's there.
Yeah.
And there's a couple of the moons at the left upper corner there. Good shot.
Yes.
Oh. Good shot, Noel.
You're upside down, Noel.
If I could point out, south is at the top on that image, and it can bring it back here. There's a barge that you can see just on the bottom side of the skinny North Equatorial Belt. I can't point to it with my arrow, but Yeah, that's
it
it.
there.
That's one. That's one of the barges that I was referring to. That's a remnant of the north component of the North Equatorial Belt, and we expect it to reform again pretty soon. The only other picture I was going to share was we've just been referring to clouds that form over the Great Red Spot. Well, in 2017, or from 2017 on, a brown haze has formed over the equatorial region, and I'm pointing to it there. That's a picture again in September. That's the brown haze across the equatorial region, but it shows up best of all in ultraviolet light. And these two bottom pictures are taken on the same days as the one above, but it shows that the equatorial region is very different in ultraviolet light. That's around about 400 nanometers, which is on the going onto border going into UV region of the spectrum, and it's quite different to what it was 4 years earlier. And that's an example of clouds or something that forms in the atmosphere of Jupiter and obscures what's underneath. And that's also what happens to the Great Red Spot when we think it has faded. It's actually under the veil of some other superimposing cloud. Rightio, we're back.
We'll jump back to Noel's view, which I just think is quite spectacular. Now we're going to jump across to Saturn, and if you like it, then you should have put a ring on it. Seriously, Anne-Marie has got Saturn in view. Sorry, I was channeling my inner Beyonce there. I apologise for that. Now, I have to say the first object that I saw through a telescope at the Melbourne Observatory on one of their guided tours was Saturn. And it blew my mind, absolutely blew my mind, to the point that I literally thought someone had stuck a photo of Saturn on the end of the telescope. And that was what got me and my family into astronomy. Being able to see Saturn and our Deep Sky Section Director's favourite, the Jewel Box cluster. But Saturn was the big one. And seeing that live with my own eyes through a telescope was just mind-blowing. And that was it. That was the end. I was hooked. So this is Anne-Marie's live version. Anne-Marie, what are you using to bring us this live vision of Saturn?
I've got my Newtonian reflector, which has got a 1200 millimeter focal length. I've also got a Barlow, a 2.5 times Barlow on it, and I'm using a very small 120 MC camera, purely just to get the color. I prefer to use the 174, but it'll just be black and white. So I thought tonight I'd throw this one on.
For all of those,
not
for all of those,
take it away.
Okay, what I was going to say was that for all of those that are noticing a little bit of a difference in the way Saturn, in fact, all of the planets appear from second to second, has a lot to do with the turbulence of the atmosphere and how steady it is or how turbulent it is. If you've got a perfectly still atmosphere, you will get the best possible images with a telescope. It's a little bit like, for those that aren't initiated in this sort of thing, like sitting at the bottom of the swimming pool and looking up through the water at somebody above you. If there's any kids causing waves or kicking hard, you are not going to get as steady an image as if the water is perfectly still. Now, substitute our atmosphere for the water and you understand what's going on, the more still the atmosphere can be, the better it is for us astronomers and the views and images that we can present to you.
Stuart, have you got anything to add about good old glorious Jupiter?
Saturn.
Jupiter
Sorry,
or Saturn?
Saturn.
No, just that
It's been a big day. Sorry.
it's a problem trying to image planets through the atmosphere. Unfortunately, we need the atmosphere so that we can breathe and stay alive. But when the atmosphere is very steady, we get the steadiest image, as Perry rightly said. And the way we image the planets is by using video cameras with short exposures, so that we can try and image the best frames, if you like, where momentarily in like a millisecond or so, you get a very, very steady image of the planet. And so we try and video it like you're seeing now, and then when we process it later on, we try and determine the steadiest frames, stack them all together to get an image that way. And that was a technique that was developed through the 1990s and the early 2000s. Firstly, using film from a gentleman, I can't think of his name now, in Florida, and then it moved on to using webcams, and now we have dedicated cameras for the imagery of the planets and dedicated software.
So is that the lucky imaging processing that you're talking about?
Yeah. So lucky imaging refers to the fact that if you're imaging a planet using video camera at a fairly fast frame rate, and the rate of the frame differs between different planetary images' opinions and their experience, but lucky imaging refers to the fact that if you're imaging a planet at any time through the atmosphere, which we all do, you can be lucky to get some very, very still frames for that momentary, for that moment where the planet is very still and very sharp. And what we try and do then is to try and add the sharpest frames together to get the best result in the end.
Barry, do you have anything to add about the wonderful planet that Saturn is? You're muted again, Barry. You'll have to unmute yourself.
Yep, sorry.
That's okay.
I believe is that okay?
Yeah, go for it.
Yeah. I believe there are plans to send a mobile vehicle to rove around the moon Titan. I'm not sure how solidified that plan is, but I hope I'm still alive when it lands and has a look.
I hope you are as well, because if anybody's going to know about it, it's going to be you, and you'll be able to tell our viewers all about it.
Yeah, hopefully.
Something. Sorry.
Another helicopter. It's another helicopter like what they've got on Mars.
Oh,
really?
yeah.
So they're going down the path of a helicopter, are they?
Yep.
What were you going to say, Perry?
I was just going to point out to our viewers, Mark, that there's an interesting thing to look out for.
Yep.
And it's one of the reasons why Saturn can look so real in a telescope. It can have a 3D appearance. And one of the reasons that causes that is not only the angle of the rings, but also the fact that the planet is casting its shadow on the rings. And you can see in this particular view, I'm not sure whose image this is. Is it
This
And
is Andy's. This is from Andy. Yeah.
Andy, thanks, Andy. You can see to the upper part of the disc of
The upper left there, yep.
Yep. Now, if you look to where the disc and the rings almost make contact, I mean, they don't really, but it appears.
It looks like they do.
At the top, Mark. Up at the, no, right, bit down. They're almost there. There's a shadowy line. No, higher up. Higher up.
At the back of Saturn.
There, right there. That's that dark line or dark part is the actual shadow of the disk of the planet being cast onto the rings. And it gives a tremendous feel of a real 3D object.
Unless, Perry, it's at opposition where that shadow is equal on both sides.
Aha.
Now you're getting technical, Stuart.
But that is it is a very interesting thing to view through a telescope, that shadow, as what Perry said.
So, Stuart, as you know, I've just started getting stuck into Planetary with my phone and the telescope. And that's the first thing I noticed. What Perry was talking about was that 3D depth that you get from live stacking, or stacking the images of Saturn, and it's because of that shadowed line at the back and then the rings coming around the front. It just gives you that real depth to Saturn.
And the other
basic equipment.
The other interesting thing is that the ring angle goes through a 30-year cycle. And I could show you. Can I share my screen?
Absolutely. Yeah, go for it.
Let's have a look.
That's everyone wants to see what we're talking about. So yeah, share away. There we go. So Stuart, there we go. Stuart, there we go. You're up.
So just from what I'm trying to talk about, in addition to what Perry was saying, is that in 30 years, the rings of Saturn, as viewed from the Earth, goes through a cycle. And you can see that in 2001 on the top left, they're opened up so that we can see the southern hemisphere. And then in 2009, the rings go through a phase where they actually go edge on and they disappear or almost disappear for about a month. And then moving down to 2017, 2018, they open up again, this time showing the northern hemisphere.
Stuart, can I get you to hold there for just one moment? Because something interesting happens when they become edge on, and you said they almost disappear.
Yes.
It gives us some real insight into the thickness of the rings, which is not very thick at all. Perhaps you've got those measurements. We know that the width of the rings is what, about 280,000 kilometres? Or round about there. But the actual thickness of them is what, maybe 1 or 2 kilometres thick? Have I got that right?
I think they may even be even thinner than that, Perry. They're very, very thin.
I think it's from what I know, like Perry, I think you're right. I think there are some spots that are, 1 or 2 kilometres, and there are some spots that are a bit thicker, and some spots that are thinner than that.
Hundreds of metres.
Yeah. So, I think the assumption is that the average is about 1 to 2 kilometres thick on average. Those rings are.
Which is an extraordinary thing if you can imagine them extending for those, 280,000 kilometres, but then you put them on their edge and they're so thin. a bit like getting a big sheet of paper, say the diameter of a big round table, and then only being the thickness of a sheet of paper.
Indeed.
Yeah.
Sorry, Stuart, please
No,
go.
it's quite impressive, isn't it, when you think about it that way?
So the next time they go edge on, we're heading towards that will be around 2025, and then heading towards 2029, where they'll be opening up again, this time to go back to the way they were at the top left, where we'll be viewing the southern polar region with the rings completely open again. So it's an interesting planet to image over this 30-year cycle.
So we have a bit of an interesting one here. This, we've jumped across. This is Neptune. Live view of Neptune from Knowles Matsukov telescope up in Bendigo. So if anyone's not seen Neptune before through a telescope, you officially now have seen Neptune through a telescope, which I think is just absolutely amazing that we can bring you this live. Now, Stuart, have you got anything to add about Neptune?
Well, it was, I think it was the only planet to be discovered mathematically, and it was discovered in the 1800s. I don't actually recall the year. It was around the 1830s, give or take a few years. And it was when after William Herschel discovered Uranus, when they were looking at Uranus's orbit, it looked like something was pulling it out of its orbit, and so through mathematics, they worked out that another body was responsible for that, and if it existed, it should be at certain coordinates, and eventually they discovered Neptune through that method, and it's the only time, I believe, I'm happy to be proven wrong, the only time that a planet has been discovered mathematically and proven.
Look, I think it was a French chap that worked it out, Stuart. Was it Leverrier? Perhaps.
Leverrier,
yeah.
Yeah.
And underneath a statue I've seen of Leverrier, the French have written words to the effect that Neptune is the only planet discovered by a pen and not a telescope.
Yeah.
I like that. That's pretty impressive. Well, they're strong words. Absolutely.
Well, it actually shows the power of mathematics.
Yeah, it does. It does. Absolutely shows the power of mathematics. And that just because you can't see something doesn't mean that it's not there. Now, Barry, have you got anything to add about Neptune? I'm still in awe that we're able to live stream
only the
Neptune.
Story of the discovery of it is a lot more interesting in that the British or the English guy Adams also calculated where Neptune was going to be, but as the story goes, his procedure was retarded by the astronomer Royal George Airy, and the discovery was actually attributed to Leverrier, but Adams has been recognised since as having almost an equal claim to the discovery of Neptune.
Well, this may be a little bit apocryphal, but I think I read somewhere that when the Germans, was it Gall and DRS at Berlin Observatory?
Yeah, they actually saw it.
Yeah, when they got the information from Leverrier as to where it should be, they went to work immediately, and within half an hour, they spotted the planet. The British, on the other hand, I think it was at Greenwich, was it? They sat around, had a cup of tea, some scones, and a nice little late evening soiree before they found it, and that's why they didn't get it.
A spot of scones and tea.
Yeah.
Yes.
I wasn't referring to that. Adams mathematically calculated where it was, just like Leverrier did. The actual observation of it was pronounced Galilei, the German astronomer. But anyway, Adams calculated where it was, and he has since been attributed almost equal discovery rights as Leverrier.
Sure. I was just being mischievous, Barry.
Right. Yeah.
I like it though. It's like you're busy having a spot of tea with scones as opposed to discovering a new planet. Sounds about right.
Back in '89, when Voyager 2 went there, they didn't know what they were going to, the image they were going to see, but it turned out to be quite spectacular. And I was actually at the, is it the University of Ballarat? I was in Ballarat at the time anyway, when the feed was coming in from NASA, when they actually saw it for the first time, and it was very spectacular.
Well, I was there as well, Stuart. It's a wonder I didn't see you, but even if I did, I didn't know you then. So
no, I don't think we knew each other back then.
Well, it's a small world, isn't it? You didn't know each other back then, but now you do. How long ago was that, Stuart?
89, was it?
I think it was 89, Perry. Yeah.
So you're talking what, 32 years ago?
Yeah.
And now you're on a live stream together.
Yeah.
Talking about Uranus and Saturn and Jupiter and Venus and.
The other extraordinary thing about the information we got back from, was it Voyager 2 or Voyager 1?
In regards to Uranus and Neptune was Voyager 2.
Yeah. Anyway, whichever.
One or the other.
We managed to get some fabulous views of some of the moons as well of Neptune, I believe. Was it Triton and whatever? Some of those pictures were just extraordinary, especially with the geysers that appeared to be belching out this black sooty material. You know the pictures I'm talking about, Stuart? The Cantaloupe moon?
Yeah, I do, yep.
Yeah. I found that was extraordinary imaging.
What were these images you're talking about there, Perry? Obviously before my time.
Triton, one of the moons.
Yeah.
The moon that looks like a cantaloupe.
A cantaloupe. Well, cantaloupe's quite tasty. I don't think Triton's tasty though. We have a question which I think is for Noel. This one's for you, Noel. How big must a telescope be to be able to observe Neptune?
Mine's about 40 centimeters long and about 20 centimeters wide, so not that big. I'll just see if I've got my picture here.
I'll see if I've got a picture here which you've got saved on your desktop.
Yeah, but it's of my new
It's almost like you planned it.
Yeah, well, these things come up every now and then. but no, I've only got a picture of. This is I give you an idea. It's a little smaller than this. This is one of my other telescopes, but the telescope I'm using tonight is probably about 2/3 of this size. You don't need something huge, but I know Stuart uses quite a large one to do his imaging, and there's big benefits in doing that. But yeah, tonight I'm using a compound style telescope, so it's does some internal reflections to increase the focal length.
There you go. That's a very good answer to that question.
In reality, though, you don't, in order to just spot the planet, you just need binoculars and a good chart to know where to look.
And a dark sky?
Yeah, dark sky does help, but you should still be able to pick it up from Melbourne, I think. It's what, magnitude 7, 7.5? I could be wrong there, but round about there. So 7 by 50 binoculars will show it. Now, you're not going to see great detail or anything, but you may just be able to pick out this very pale azure blue colour. And that may give it away slightly, but yeah. And even large telescopes from Earth, even much larger than what Knowles is there, struggle to give us any detail of the ice giants, Uranus and Neptune, because they're just so far away. So don't expect to see too much. Being able to spot them at all and perhaps discern that very pale bluish colour is enough, I think, to satisfy us.
I would agree with that, absolutely, Perry. I think they're very wise words. That you're not, unless you've got the most amazing equipment in the world, you're not going to see much more than what we're seeing right now through unprocessed live vision, be it with your eyes or through a telescope live on the internet. This is a pretty impressive view of Neptune that we're looking at. We've got a couple of guys trying very hard to see if we can get Uranus, or I'm going to ask you, how do you say it? Is it Uranus? Is that it?
Yeah, Uranus.
Uranus.
And the reason I should explain, Mark, whilst
go for it. Explain away.
The reason is all the planets of the solar system are named after the Roman gods of the sky. So you have Mercury, Mars, Jupiter. However, with this particular planet, it's the only one that's named after the Greek god of the sky. So in the Greek, there is no U sound. It is an U sound. So it is Uranus.
Uranus. So is there a reason why it's the only Greek named object? Is there a reason why it wasn't named after a Roman god? Or I'm actually asking as a legitimate question now.
That is an excellent question, Mark. I have read it somewhere, but I have also forgotten it. So I'll take that on board and Google to my heart's delight.
There you go. You're going to have to Google that. And tomorrow night, before we start the Deep Sky live stream, I'm going to ask you about that.
You will be asking questions, right?
Yeah, I'm curious to know. I really am curious to know. So, Lee, sorry, not Lee, Noel. Same question. Well, a camera for recording. So we've spoken about your telescope. What are you using to image? Can you use a DSLR to do this live stack like we're doing?
Now that's a good question. I'm going to say you can. The difference is that the camera I'm using, I guess it's recording video, and that's like Stuart mentioned before with the Lucky imaging process. Is I'm looking at a lot of frames coming through here. If you've got a DSLR that can record video, or maybe even give you a live feed of video, which many of the newer ones can, then you'll be able to do that. One of the downsides in using a DSLR is that you won't be able to control what they call a region of interest. So with the camera that I've got selected here, you can see on screen there's this little pane that I've got the I wonder if my mouse is moving over it. There it is. In the on the right hand side and the just above the middle here, I've actually told the software to ignore all of the sensor data except for a small area in here. And that means that there's nowhere near as much data coming through. So I'm getting a higher frame rate than I normally would. Anne-Marie mentioned earlier that she's using an ASI 120 camera, which has got a fairly small low-res sensor on it. And that sounds, you might think, oh, that's got to be pretty ordinary, but that's actually ideal compared to a DSLR, which is quite a large sensor with big pixels, relatively speaking, and a large number of them. You've got a huge amount of data coming through. You want to be able to get a lot of frames through, so you want and you want to ignore everything else. So you just want to be able to zero in on that region of interest, which will just be that little planet. Or region of surface, and then discard the rest. And you just can't do that with a DSLR. So not impossible, but not ideal.
There you go. So we have another question as well, which the Astro guys might be able to answer. Andrea is after a new telescope that I can take photos of with my Panasonic DSLR. Any recommendations? Who wants to jump in?
It's been a long time since I've seen a Panasonic DSLR. Is that, how old is it? That's probably.
Let's just assume that it's fairly recent.
Yeah.
Probably just a Newtonian, nice and F5 or something like that.
So an F5. So when you're talking F5, what are you talking size-wise?
Well, I've got a
size of mine. It's huge.
Size of
I'd
you're not allowed to answer this question. You've got
the ED80s are so good with DSLRs.
Did you say ED80?
Yeah.
I've got.
I mean, they're not particularly good for the planets, but they're great for all sorts of other deep sky stuff.
For wide field stuff.
Mm.
Yeah,
and there's some good wide field lenses too.
I've actually got an ED80 coming my way.
Yeah,
which I'll be using with my phone. Not a Panasonic DSLR or not a DSLR at all. It's a phone camera, but I'll be using an ED80 like Anne-Marie said.
It also depends whether the DSLR is just a straight DSLR or whether it's been modified.
Let's assume straight. We'll assume straight, unmodified for the moment.
Look, you'll get lovely photos of Carina and things like that with an ED80. If you want to shoot the planets, you've got to go bigger. Like they said, the Newtonian fast one, F5.
So it's the latest model DSLR. So we're talking 2020, 2021 model is what I'm seeing here. So Lee, you got anything to add to that or?
No, not particularly. I've got a 5-inch Newt myself, which I've had for many, many years. It would have been an old what was it? It was an old Tasco, which was what National Geographic or Australian Geographic used to sell. So these days, I probably wouldn't go anywhere near one of those type of things. But this has got a good solid mirror in the back. It provides some fantastic images. So you can pick those up for $50. That's sort of that range of how much you have to spend for a telescope that's a decent size.
They're not really
be able to get
beginners ones though.
Sorry?
You've got collimation problems and things like that. They're not really a good one for a beginner to start out with.
Yeah. Look, it sort of depends on what the budget is too. That's the key.
Refractors can be expensive.
I guess what we would recommend, Andrea, is if you're not an ASV member or if you're in Adelaide and you're not an ASSA member, if you're in Adelaide, become an ASSA member. If you're in Victoria, become an ASV member. Both societies have some amazing deep sky sections that can help you choose your telescope to suit your camera, basically. In fact, Mark Sanson, an ASV member, has just piped in. Some DSLRs have what's called crop movie mode, which only uses a small fraction of the sensor at 1:1 pixel resolution. So it really does depend on the camera you've got, what the camera is capable of, and then from there, what telescope is going to suit that camera. Now,
and the mount.
And the mount. Well, the mount is the most important thing, I'm told.
Absolutely.
I'm not a deep sky guy, but I'm told that the mount is the most important thing. Now,
Yes.
I believe Andy has Uranus, and I'm going to say it properly, Uranus, live for us. There we go.
That's it.
There we go.
And
That is Uranus live from... So, Andy, what are you using?
Well, I'm using this camera. It's an ASI 120. It's a little color camera, and I've cropped it to wherever I've done it. Just cropped. I mean, where are we? Here.
You're at 200%.
Yes, 200, but it's actually, look at my region of interest, it's tiny. So I'm actually looking the center, and it's zoomed right in because this is my scope here. It's a 6-inch Newtonian. But that's a DSLR, which I normally use, but I've just put a Planetary camera in there. And I also use the same camera for my guide camera. So this is a scope I use for pretty well everything at the moment. And like Anne-Marie said, it's a big learning curve from just grabbing a scope and a mount like this and then just start even finding stuff in the sky, let alone imaging it as well. But like you said, with come along to the meetings and meet people, and it's the quickest way to learn. But I'm not getting a very good picture of Uranus at the moment because it's I can even see fringing with my the blue on top, and it's such a tiny object for my gear. You really need like a 12-inch telescope really to do this justice at the moment. And plus it's looking on the eastern horizon, not quite horizon, but there's a bit of movement there. Yeah, it's pretty low on the horizon. It's only, say, like 20 degrees off the eastern horizon. So there's a bit of, if you look with the eyes, there's a lot of twinkling of stars, which means the atmosphere's moving a bit. When it gets up towards the meridian, which is the middle, it'll be up. It'll stop twinkling, but this is about as far as I can see. Just a bit of a blurry dot, but it's definitely Uranus. First time I've actually imaged it or looked at it.
Yep. Sorry, we just I wasn't looking at the messages at the moment. Mark's just had to quickly duck out. He has rain where he is, and his scope's out. So
well, here's something here. Today I had to go to Nil, and this is where I went past. So this is where we should all be today, tonight.
Yep.
But yeah, I took this photo today of me standing in front of the gates as we're driving past, and about 11 o'clock, I think it was. I'm thinking, well, I should be actually turning in here and going and setting up, but we're not this weekend.
Not quite.
Maybe next year.
Maybe next year, yes.
It's a very good place.
I've never been up. I know how clear it'd be up in the desert, but yeah, I've been hanging out to go. I've missed 3 now. And I was really looking forward to this year and missed it again. But here we go. Yeah, so that's my guide scope. Image of the same thing. I shall turn off my. Yeah, that's definitely Uranus with the star next to it is. I think it's just a no-name star. It's a Ari. ARE37. So it's actually named star, but right here, that's definitely Uranus with my guide camera. And here's my main camera, and it's not it's not doing justice of, you need 12 to 15 inch scope to really see this, and then you're pretty going to
16
see
would be nice.
a 17-inch plane
Well,
wave or something like that. That'd be great.
Our illustrious president of the ASV has a 16-inch that
Oh, really?
I
Wow.
think
I've
Stuart's,
tried I've tried imaging this with Chris through 16, and Uranus and Neptune are very difficult to get any sort of detail at all because of the makeup of their atmosphere.
Mm.
So what you try and do is there's filters that are broadband, but basically down in the infrared area to try and enhance the features of these two planets. But so far, I've had zero luck getting any sort of detail on Uranus or Neptune. They're not very easy planets to image at all.
Okay.
Now, I got to jump in here just quickly, Stuart. Lee, I know you're in Ringwood. It just absolutely opened up in Bentley.
right.
Perry, I'm sure you can hear the rain as well. It's come from nowhere.
Heavily on my roof.
Yeah, it's come from absolutely nowhere. I've had to just quickly run out and grab my gear inside because it was meant to be clear skies all night tonight. So, Lee, I would highly recommend being in Ringwood. Go out and grab your gear now.
I can actually see if I just quickly
before it hits. Before it hits, absolutely go and grab what you
so
can.
you can see it just popping up over there now.
Hang on, let's just jump onto your. So Lee's got a all sky camera, and you can see that cloud coming through, which we were not expecting.
Yeah. That's coming in from the south right now, so I
that's
will
where
actually.
I am. We weren't expecting that cloud at all. It was meant to be completely clear tonight in Melbourne, and good old Melbourne has decided you're out of lockdown. I'm going to rain out of nowhere. So sorry, I had to run off and grab the scope and bring it in. So apologies for that. We'll jump back.
It's trying to hit all the people coming home from shopping at Kmart and Big W.
Oh, clearly it is. Clearly it is. I just hope it hasn't ruined the telescope now.
And Bunnings. They were all able to get in at Bunnings.
I'll let it dry out and hopefully it should be fine. Now, I think we might be close to wrapping things up for the night. We do have a weekend's worth of live streams coming ahead for everybody. I'm just going to jump back to all of our attendees now. So we've got tomorrow morning we have. So I've got my hair everywhere now. Tomorrow morning we have an astrophotography session at 11 a.m. with Tom Fowler, the ASV astrophotography section director. He's going to be looking at exoplanets and hunting exoplanets from your backyard in suburban Melbourne when it's not raining. Following that, we have a talk on. Bear with me. A talk on because I really think this is actually quite interesting. It's a specific comet, the Christmas comet. Perry, do you know anything about the Christmas comet?
Yes, it'll be visible at Christmas.
That helps me wonderfully.
Wise man, huh?
I'm trying to think of that. I should know the name. I've written it that many
maybe
times.
we should call it the Star of Bethlehem.
The star. Well, unfortunately, it's called C2021 A1 Leonard, a Christmas comet.
Similar.
That'll be from 2 p.m. tomorrow.
Pretty sure that's what it was described as 2,000 years ago.
It's much more exciting than a Christmas comet. That's at 2 o'clock. 4 o'clock, we have the quiz with Fraser Farrell, who is from the Astronomical Society of South Australia. So if you're a quiz master, Lee, I know you're a quiz master. Jump on and join in that stream and see if you can answer the questions. And then from 9 o'clock tomorrow night, most of us here will be back for Deep Sky. We've got a list of objects that we will be looking through or looking for and looking at that we'll bring you. And then following up on Sunday, we've got solar eclipse talk from Dr. Rod Hill, talking about solar eclipses. And following Dr. Rod Hill's talk on solar eclipses, we have a live stream of the sun if it does not rain in Melbourne, which will be brought to us by Dr. Russell Cockman. So once again, thank you everybody for joining us tonight. We hope you enjoyed our stream. If you're currently not following the ASSA or the ASV on Facebook or YouTube, please do. Hit the subscribe button on YouTube or hit the follow button on Facebook. Both the Astronomical Society of South Australia and the Astronomical Society of Victoria would greatly appreciate that. And we will see you again tomorrow morning for at 11 o'clock for the astrophotography session on hunting for exoplanets. Until then, we'll see you next time. Thank you very much for joining us, and thank you to our guests tonight for bringing us the information that they've been able to share with you.
Nope.
It's not going to work for me.